So in the previous video, we've been working on the direct integration support for the HoneyComb LX2. The legs are getting soaked. It's been raining heavily here and all of the heather is absolutely soaked. I've written all of the code to flash the firmware to the SPI flash, and now I just need to create the tests. So I thought, as I was out for a walk this morning, that I would just think about what those tests might be and make a note of it. Actually, this looks like a good place. I think there are 3 scenarios that I need to test for. The first is where we can't determine the hardware profile. We can't find any known version of the firmware on either the SPI or the SD card, in which case we'll mandate or strongly suggest that the user flashes the firmware. I don't think that's generally a valid state for Slackware. You should find the firmware on at least one of those 2 storage devices, but I want to cater for the option where people are building the firmware themselves from source, because it is an open source firmware. The second one is where we've determined the hardware profile from either the SD card or the SPI flash, and it's a known and packaged version, meaning that it's a version of the solid run firmware, or it's at least one that we've built, that we're distributing with Slackware. So we found it on either one of these 2 devices. If we find it on the SD card, but we don't find it on the SPI flash, then we'll strongly suggest that you flash the firmware. But if we find it on the SPI flash, and again it is a known version, it's one that we're shipping in the OS, then we will provide that information to you and not recommend that you flash it. You'll still be able to, but you don't need to. The third option is where you're running an older version of a known firmware, but it's not one that we're packaging, because typically we'll only be packaging the most recent versions. In that case, we'll surface the information and I've said mandate a flash there. We don't have to flash it, nothing's mandated, but it's suggested to you that because there is an update you might want to flash it, but it's not actually, I won't mandate that doesn't make sense. We'll make that check on either boot source. So these are the 3 high level test cases or scenarios that I want to test for. Okay, so I think I'll head back now and test these this afternoon. These are my favourite trees actually, the Scots pine. I tried to plant one in my garden but it died. Where the hell am I? Okay, so the first thing we need to do is power on the machine that I use as a serial console. Usually this stays powered up, but we had a power cut, so yeah, this is a really old 32-bit X60, an IBM X60. It's actually IBM, it's that old. But this runs 32-bit Slackware X86 just great. It runs current. Well, actually, it runs an older version of current. But yeah, so I use this for my serial console, so I can access the serial console of in this case, it's just the Raspberry Pi 4 and the Rock Pro 64, I think. Oh, well, and the Pinebook Pro when that was working, but as you can see, that I put the lid back on, because that's still broken. But I've been in touch with the Pinebook Pro guys to see what we can do about fixing that. So yes, I've booted that up. I then need to boot up the Rock Pro 64, because the Rock Pro 64 is I'm going to do the development on the Rock Pro 64. And so this machine is going to pose as a HoneyComb LX2. So I'm just going to hard code the flashing tool initially, just to say it's a Rock Pro, to say it's a HoneyComb LX2, but obviously it's actually a Rock Pro 64. But the reason I need to do this is because the Rock Pro 64 has an SPI flash and an SD card. socket. So I'm going to use the Rock Pro 64 to validate my code that will eventually run on the HoneyComb LX2. The SPI flash is large enough on the Rock Pro 64 to accommodate the HoneyComb LX2 flash, which is about 8 megs in size and compressed. The U-boot code that we flashed to SPI is a few hundred K, just to give you an idea. So fortunately, Brent has checked that the spec is good on this one for me. So let's just log in as root here. Okay, so I was hoping just to see in here what the TTY was. Grab USB 0. But the thing is, it could be USB 1 because actually I've got this one for Pepper. So this is the USB to serial converter for Pepper, which is the Rock Pro 64. But then I've also got this one for the Pinebook Pro. Actually, I suppose I could just disconnect that one in this case. Usually this machine has 3. It has the Raspberry Pis, Pinebook Pros, and the one for the Rock Pro 64. But given that the Pinebook Pro isn't actually turned on anymore, I could just do that instead. That would make my life easier. So what we're going to do, let's just see T2Y USB. So it's USB 1. Okay. Console. It's SP1, yeah. Rock Pro 64. Okay. So I'm just going to run the script to attach itself to the serial port of the Rock Pro 64 like that. There's nothing there yet because I haven't turned it on. And then now I should just turn it on or plug it in rather, and it should automatically boot. You can actually get the cable in there. There we go. Yeah, there we go. So the Rock Pro 64 is booting like that, and we should see it booting here. Yeah, there we go, with my water bottle in the way. So yeah, so we're going to see the Rock Pro 64 booting on the monitor as well. So now the thing is, I don't know what state I left this machine in, because this one's usually I use this Rock Pro 64 in my office as a desktop testing machine. So I test, KDE and XFCE and the graphical components. Usually I leave it in a good state, but you never really know. That's booted correctly, so I can now, you can see it's running, well, it's running an old version of the kernel. Well, it's not that old. At the time of making this video, it's actually not that old. It's a few weeks old, maybe a month, maybe, I don't know. But yeah, so that's booted, so I can now log in remotely and begin the development. So the first thing that we need to do is remove the SD card from the Rock Pro 64 and replace it with an empty SD card. Because on the Rock Pro 64, let's do that. So on the Rock Pro 64, the boot partition /boot resides on the SD card. So it actually occupies the SD card as part of the operating system footprint. And on the HoneyComb LX2, that's not the case. We don't use the SD card as part of the operating system. So what I need to do here is I need to U-mount the boot partition and then physically remove the SD card and replace it with an empty one that I can use for testing. To do that, I'll just unmount /boot with U-mount like that. It won't be there anymore. And then I'll type sync to synchronize any data that's yet to be written. So then all I need to do is physically remove the SD card. Then we need to get ourselves an SD card that's spare. So, see, I'm using the the Rock Pro 64's Wi-Fi adapter box. The Wi-Fi adapter, or rather the Wi-Fi module, there's actually the one that's in that Rock Pro 64 that Pine64 sent to me as a donation to the project. It came in this little box, so I reused this little box to contain my SD cards. So that'll do. Let's use that one. I don't have many to spare actually. I thought I had more SD cards than that. Well, there's 2 there, but where's the other ones? Oh yeah, they're on there. Oh yeah, right, yeah. The other SD cards are from the Pinebook Pro testing. Okay, Right, that's where they've gone. Okay, so we'll use that one. Put that back in the box. And then we need to extract the SD card from the Rock Pro 64, which actually, where is the SD card slot? Where's the SD slot? Oh, don't tell me it's on the other side. I think it is, isn't it? Oh no, hang on. The SD card slot's actually on this side, so you can probably see it. Well, maybe you can't actually, it's too dark, but there it is. So we'll put that safely with the screws on top of a box of butter. Actually, I wonder what's in there. But I won't lift that up. But these are all the screws from what remain of the from the Pinebook Pro. I lost a couple before I realised that you had to tape them or somehow secure them to the lid. So yeah, we'll put that up safe. We'll put that safely there with those, and then then we need this one. Now, I think the orientation is that way around. Okay, it made a nice clicking sound, so that's always a good start. Yep. Okay, so it should be there. MC Block 1. We're now ready to begin development. It's the next day. I've had a chat with Brent because I've already developed some code and I've got him to test a little bit of it on the HoneyComb LX2 because I don't have mine yet. I'm just going to review the spec. So basically it's a bootloader, rather a firmware flashing tool, and we've got a couple of scenarios to handle, and those are being run from within the installer in the post-installation phase of the Slackware installer and on an ad hoc basis within the OS. Just on the workflow, so the idea is that we want to be able to, if possible, determine what the hardware profile is. So the hardware profile is the speed of the RAM, the speed of the SOC, the fiber port config and some other stuff. So we want to be able to determine that up front without the user having to select it, because it's just one of those details that I appreciate for myself. So that's why it's in there. So the way that we're going to do that is by querying the existing firmware. Now, the existing firmware, in order for the Slackware installer or the OS to have booted, there has to be the firmware somewhere, and that would either be in the SPI flash or the SD card, and probably also the eMMC. Although we're not that's not in scope of Slackware, because you could use the eMMC storage for something more useful than firmware. So for us, it's just a case of, okay, the OS or the installer's booted. What firmware are you running? You must be running some, and we'll query it to determine if it's a firmware version that we know about. And the way that we know about that is because where are we? Sources, firmware, checksums. Because we have a checksum of each of the solid run firmware types that are available on their website. We have a checksum of the first 100K of each of those. And so if you're using one of those, we'll be able to determine, based on the checksum, what your profile is. So in this case, it's the SOC is 2000 or 2 gigahertz. I think it's the, what is that? Is that the bus speed? I think that's 700 megahertz. And then this is the speed of the RAM, so 2.9 gigahertz. So we'll be able to determine what your hardware profile is, and then that simply just helps the workflow, and it helps explain what it is, what your hardware profile is on your system. So it's just a nice touch, really. Now, oh yes, there was one final thing I wanted to look at on the spec. So this is basically, we're going to query the SD card and the SPI flash if we can determine what the hardware profile is. And then in here, I said within the installer, we'll check the SPI flash first, and then we'll check the SD card. But within the OS, we'll only query the SPI because the SD card isn't part of the Slackware footprint. So you may not have an SD card in there. Now, but then as I was writing some of the code, I thought, what's the point in that? We don't need to restrict it. It could be that somebody has booted, for some reason there's been an issue with the SPI flash, and they've disabled it and they've booted the Slackware OS with firmware on the SD card. I mean, that's possible. and they want to flash the SPI flash. And so actually it makes sense to just query both, regardless of which environment we're in, because we're only querying it, we're only reading it, we're not writing anything to it. So it's a non-disruptive query. So actually, I'm not going to do that part anymore. Okay, so that's the spec. Cool. So what I've done so far is I showed you the other scripts here that download the source, so I won't look at those again. I haven't touched those since. So here's the script. This is a work in progress right now. And just to call your attention to the top here, this line here, well, it tells you what it does actually. So this is going to be a reference script, just like the RK3399 is, and many of the others in the OS. So this is going to be a reference script. So when you want to light up Slackware on a new hardware model, and you're a competent sysadmin, or you're a developer, or whatever you want, whatever skills you have, and you think, oh, I can get Slackware running on other hardware models. Within the OS, there's lots of scripts and documents that are inline, so you can read and understand what it is you're reading. So I've been quite cognizant of the fact that when you're digging through an OS or you're trying to understand something complicated, it really helps to have examples and explanations in line. So there's quite a few of these here. And this one here is just, if you look at package tools, and then you go to run the setup scripts again, then you'll see here, so it's already populated because I've installed the package. So you'll see here that text is now within this tool here, and the same with the RK3399. Okay, right, so let's have a look at the script. So at the top here, this is just the standard BSD license clause, which essentially says, I've written this thing and it works for me. It might not work for you. If it doesn't, that's your problem. Don't blame me. You can use it and take it and do what you like with it, essentially, as long as you include all of the original license text and the original author credits. Because it's not the GPL, the BSD license doesn't mandate that you pass anything back upstream. But given how open source works, if you do make some good improvements or fix bugs and so on, it is appreciated that you send it back. It's just not mandated. So that's a difference there. All right, so it's a bit of information about where the script gets called from and that kind of thing, so you can understand it. And also, when you work on this stuff, it really helps to include the references that you used for yourself. So, in my case, I found this one incredibly useful because it explained what the naming convention was and various other useful information. So I always include these. Eventually, though, what happens after 20 years is that these URLs don't exist anymore, and eventually I do check them from time to time, and eventually I just clear them out because they don't work anymore. Although I try and retain the original author credit wherever possible. Okay, so there's a little bit of information at the top here just to determine what the root file system is, so that it works within the installer and it also works within the OS. And there's some temporary space to decompress the compressed firmware files. And then we just do a few sanity checks, really, just to make sure everything's in order. Yeah, a few other things. So I've taken most of this code here has come from the RK3399 code. So I don't need to test any of this. I already know it works. I can just use it. All of this code is new, this stuff here, but I've already tested it, as you may have seen in the previous video, so I don't need to retest any of that. Well, I will test it because I'll be writing. I haven't finished writing script yet, but yeah, it's already. I know that it already works, so I don't need to test the intricacies of it. Yeah, no, that's all tested. Blah blah blah. So basically, there's a few bits of here. So here's some new code that I've written the other day. So remember that we want to query the SPI flash and the SD card. So I've written some functions that do that. And when I say query, it just means it's using DD to read the first, in this case, 100K of both of those devices, store SPI and SD card. And if we were able to successfully read it and generate an MD5 sum, then return the MD5 sum. If not, if it failed to be read, then we return an error code instead. So we've got a bit of code there. And now this piece of code here, I just had Brent test this last night. And I said to him, how do you address the SD card? What's the device name in /dev? And he said, oh, well, it's MMC BLK1, but it could also be 0 depending on the boot. So in the HoneyComb, the same as particularly on the Raspberry Pi, the device names, they change throughout the boot. So, on one boot you'd have the eMMC occupying MMC BLK0, and then on another boot it would occupy MMC BLK1. So this bit of code here just verifies that there is an SD card or some kind of MMC block storage, I should say. It verifies that there is some MMC block storage available on the system by just checking the proc partitions interface. And if there is, then we again query that interface to extract which MMC block devices are available that are of the type disk, not partitioned, not individual partitions on a file system, or rather not file system, individual partitions on the partition table. So it queries that. We generate ourselves a list of MMC block devices, and then if the device is available, we read, well, it would be available because otherwise it wouldn't be in here. So we don't actually explicitly check if it's available because that's done by the kernel. We don't need to do that. So what we do need to do is we need to read the device type. Now for SD cards, we can use the sys interface here and just check the contents of this interface here. And if it's SD, then we generate the checksum and and then return the status code, whether it's an error or it's not. So this bit of code basically handles the fact that the SD card and the SD card and the eMMC can alter positions between boots. That's why we've got this code here, rather than just querying a static interface or statically named interface. As you can see here, I've reminded myself quite extensively to remove this statically configured hardware model name, because at the top we populate this variable HWM, which means hardware model, with the output of this tool here, SLK HWM discover. But obviously I'm running this on a Rock Pro 64, not a HoneyComb LX2, and so I have hard coded it temporarily, and I need to remember to delete it once I hand over to Brent to run it on an actual HoneyComb. Okay, so then we have some case statements that just basically check what set some variables based on the hardware model name. Do a little sanity check, make sure we've actually found a supported model. Then if that's the case, we'll then just verify that we can query the SPI flash. So we're just going to read 100k of it. Actually, thinking about that, seeing as we don't need to read 100k. Let's read 5k. In fact, 1k is enough. All we're doing here is just ensuring that we can read from the SPI flash. We don't need to read very much from it. We just need to read a little. So I could actually read even less than that, but 1k will be fine. It's just an arbitrary figure at this point. If we look up here a little bit, we've got these two functions. In shell scripts, you always have your functions first, because if they're not already defined, you can't refer to them. So all of the functions typically live at the top of scripts. Here we've got a function called SD checksum, which, as you can imagine, generates a checksum of the SD card if it's present, and this one calls another function, that flash test function again, to generate a checksum for the SPI flash, like that. So that's what happens there. So we've got two functions to read one of each interface. What we're going to do is query both of those. We're just going to query in a for loop those two interfaces. So what I've done here is I've just put the names. We've got a for loop in, and then we've included the two names of the functions. So we've got the SPI checksum function and the SD card function. And then we're going to populate a variable called checksum through the evaluation of that function, which basically means that eval runs that function. This is you could write this code in many other ways. This was just the one that came to me because my mind thinks in this way. So this is why I've written it like that. Also, because the way that I now develop Slackware is in smaller time windows than it was a few years ago. So now I tend to write small discrete functions and then just refer to them. So sometimes there's more functions than you really need, but it means that the logic is easier to read and easier to think about. So I do it like that. So that's okay. So we generate the checksum from the device if we can, if it's readable. Currently tell you what the checksum is, although it won't do when we when the script is finished. Then we check the error code. Then, if we were able to, oh, that won't work. Why won't it work? Because it won't work. That wouldn't have worked because it would have had the error code from, or rather the return code from the echo statement, which would have always been 0, would have been successful. So we need to actually capture, originally it did work because I put this echo in afterwards, but I have actually tested this code. So what I'll do instead to make that work is just capture the return code from this into this variable and then test on the variable instead rather than the built-in one. Okay, so then what we do is we query the checksums file, the inventory file, for our file name. Oh, rather, no, we don't. We query it for the checksum, and then we collect a file name from the inventory. And the inventory is the one I showed you earlier with the file names and the checksums. And if we were able to determine a file name so that the variable isn't null, then we just break out of the loop. You know, you have to pick one or the other. Even if we had, suitable firmware on both the SD card and the SPI flash, we have to pick one of them. So, there's no way I could make it more complicated by checking if they both had the same hardware profile, but I'm not going to do that. That's one step too far. That's serious over engineering. So at this point, we're going to pick the first one that we find, which in our case will probably be, particularly when you're inside of the OS, it will probably be from the SPI flash. And then currently we're just going to output the file name that we found and tell you what the hardware profile is. So that's as far as we've got. So what we're going to do at the moment, let's just run that script, and you'll see that we've got two separate checksums. So we've got one for the SPI and one for the SD, but we don't know what the firmware file is. Why is that? Because the SPI flash on this Rock Pro 64 contains, well, let's see. Let's show you what it contains. It contains the Pinebook. It contains the Pine 64 Rock Pro 64 U-boot. So that's what is in the SPI flash on this machine. And on the SD card, there is I don't even know what's on there, to be honest. It's got some Windows partition. So I don't know. Could be anything. Okay. So that's why we don't have a firmware file name yet. So what I need to do now is flash one of the solid run firmwares to my SD card. So it doesn't matter which one I pick at the moment. So do I have the instructions of how to flash them? No. Okay, I'll just remember what it is off my head there. So these are compressed, so xzcat. Well, it doesn't matter which one we pick, so I'll just pick this one. So I'm just going to write that firmware. Now hopefully, popd. So now hopefully this will. Have I made a mistake? Has exactly the same firmware on it. Oh no, it doesn't. It's just got the first few letters. Okay. That's interesting. I wonder if that one's not in there for some reason. It should be. Checksums. It's this one, isn't it? It was, yeah, no, it's this, yeah, let's take this one. Wait. Have I made a mistake when I did this then? I might have done. So those are all the SPI. Oh no, they're here. Oh, okay. For some reason, those aren't in there. Okay. I'll look into that in a minute, but let's just check that the SPI firmware works. So what I'm going to do here, I've tested this already, so I do know this. So I'll just show you this one works. This one, so we're going to unpack the SPI firmware. So this is the version of the firmware that's packaged so that it boots off of the SPI flash. Whereas the other one, these ones are designed or a package so that they boot off of an SD card. So that's the difference. So we're going to unpack that to a temporary location and just flash it to the SPI flash. So I'm just going to run that script like that. And that's going to flash that. And in the meantime, let's just quickly have a look at this. So let's see how it does this. So I'll just do this manually at the moment. And that would be 100K. Right. So what I'm going to do here is just query the file directly. Oh, I need to unpack it, don't I? Okay. Oh. Ah. Whoops. MD5 sum. Okay. So we have generated our MD5 sum of the first 100K of that file, and okay, and pop the flash. Oh, okay. So at the moment you can see that. So the flashing must have finished. Yeah. So I've flashed this version of the SPI flash, or rather this version of the firmware, to the SPI flash with this little script. It's verified, it's complete, and I've just run the tool again, and you can see that this time inside the SPI flash we did find a known version of the firmware with this checksum for the first 100K, and here's the file name from the inventory, and here's the hardware profile, and we've exited because we found, we don't need to query the SD card because we found a hardware profile already. But what I'm going to do now is I'm just going to change the script. I'll do it here. No bootloader. So let's just change that. Change the order just to debug it. That thing. Where is it? Where's the for loop? Oh, here it is. So let's just do that. Chop that. Stick it here instead. Okay. So let's see what we get from this. It's a good test of the code because it is behaving how I want it to. It's just that it's not finding the firmware on the SD card, but the code is working properly. Other than that, it's created a checksum of what's on the SD card of the first 100K. Couldn't find a known profile as we know, and it's moved on to the next device, which is the SPI. Queried that and found the profile as we expect. Now this is, what's the thingy jig? What's this? So is this the same as that? I think it looks like it is from eyeballing it, but we can just easily test that. Oh, I don't know where I got that from actually, hang on. Right, so this is the SPI, that's from the tool. Oh, did I put a 9 on it? Right, equals, and then the one that we read directly. Oh, actually, yeah, because it's not an integer. It's a string. I forgot about that. Oops. Yes, right. So those two. Oh, I cleared the screen by accident. Those two are the same. Good. Okay. Okay, so that's interesting then. So in that case, why are those not correct? Strange. I'll tell you what, let's just now we know. Let's do this. Let's just test a different one. I think it was that one I did before, wasn't it? So if we do this one, xzcat, this doesn't, on the Linux console, when I use a Linux box, you can yank inwards to the cursor and pull out an entire word, but it doesn't. I can't get the key mapping working on the Mac. So I'll have to just do it individually. Right, so let's pick that one. And then, yeah, let's do that. It's definitely pepper, yeah. Okay, so we've catted the whole thing. So then, let's run this again, see what it tells me. Okay, so we've got a different checksum, dd. Let's just put this into here. Okay, but this time we're going to pick. So I just want to generate the checksum of this one for the first 100K as well. I'm wondering, because if these are, this also doesn't exist, CS, then that kind of tells me that I think the checksum generation of the from the source download script is wrong. So firmware. Okay, so that's the yeah. Okay, so grep. Oh, I need to uncat it. Then I checksums. Grep this. Right, it's not there. Okay, so right. That means that this must be busted. Shipping. What does this do? Of the older ones. Okay, so here we generate checksum some FW. We should 100k. Okay. That's strange. Okay. I'll have to look at that. What I'm going to do, I'm not going to look at that with you guys because I need to dig into that one. That will take a while. But the SPI stuff works. I'll tell you what I'm going to do though. I want to make sure that the script works. It doesn't fail when there is no SD card in the socket. So at the moment you'll see MC block 1. We have the SD available. So what I'm going to do is, if we look at the D message, we'll see that there's some information about MMC block. So what I'm going to do is just put foo k message. So I just want to make a marker in D message so we can see what's going on. So again, if we run the script, we'll see that we're able to query the checksum from the SD card. But I'm now going to remove the SD card from the machine. I don't need to mount anything because I haven't mounted it in the OS. It's just sitting in the slot. So what I'm going to do now is just remove the SD card from the slots. Right, like this. Now actually this isn't as easy as it is if you don't have hold on, I need to hold those so I don't pull the storage out. Okay, yeah, this isn't as easy with it in this position. But basically the slot's down here, and this is easy to do when it's not in this case, but this particular case does make this somewhat difficult. And fortunately, come on, out you come. It seems to catch on the case, whereas there we go, it's out now. Let's try and stop that falling over. Right, yeah, so you can, and if you probably can't see that on the video, but it is out of the system. So now if we do dmessage again, you'll see that the card has been removed. And if we run the bootloader flash, it shouldn't break. Yeah, it doesn't. So it's not breaking, it's just not returning. It's just a null string, and that's fine. We handle null strings there. And then yeah, and then if we just put it back in, because I obviously need it for the next bit of hacking. Let's put that back in again. Yeah, this is much more. This case. Go on. Oh, there we go. I heard the nice clicking. Right, you can sit back down now. Right. Then, if we do it again, we should be reading that checksum. Cool. Okay, so I'll figure out what's going on with the SD card stuff now. Okay, I think I figured out what the problem is. And I'm just going to put on a bit of Chris Luno, because his house tunes just, they're like fuel for the mind. Just go in there, get these pumping beats going on, and that's when the code comes out. So we'll get Chris Luno going. Unfortunately, I can't play his music on my channel because I'll probably have a copyright infringement. But nonetheless, I enjoy listening to Chris Luno, and look at the beautiful views he has. And this one up here, he's doing it in the Dolomites, and there are actually, it's not a background, there are actual people walking up on hiking around there. Yeah, I mean, I need to be this guy, but I'm stuck in an office hacking on shell scripts. But nonetheless, let's go. Right, so I discovered what the problem is, and it's actually pretty straightforward. So I've deleted the firmware that we'd downloaded and organized, and I've re-downloaded it all because I discovered in this script here that stores the firmware, so it slice and dices the firmware and just picks the stuff we want and generates the checksums. Here we generate the checksums for the firmware, for the SPI firmware we're shipping, and we generate for the older stuff that we're not shipping that's on the Solidman website. So we do those two things, but then we only generate checksums for the SD cards that we're shipping, or the SD card images that we're shipping, not all the rest. So what we need to do is we need to generate checksums for the older SD card images. We need to copy this and paste that out. Now I understand, because the firmware, I've done it, it's actually the other way around to what I just said. So we're generating the firmware, we're generating checksums for the older releases of the versions that we're not shipping, but I'm not generating them for the versions that we are. That's why the version, when I unpacked it to the SD card from the directory we're shipping, it didn't exist in the file. That's what's happened. So I've got it the wrong way around. So actually, we just need to, it would be this, yeah, so something like this. So this is where so firmware SD, I think that's what we need. Firmware SD, yeah, because it moves, yeah, so that's what it does. So in this one, it says copy latest firmware here. But actually, it's not that it copies the latest firmware, it moves the latest firmware. Okay, so what we should need to do is we just take this one, because that's where it's moving it into. Let's double check that that's actually correct. Yeah. Okay, so then older releases. So that's actually the older releases. This is the older releases. So, okay, so this is the current releases. So let's change this like that. Oops, okay. That should fix it. So if we run that script, oh, not on there though, that's not a build machine. So we now have our firmware SPI again, and we should also, do we do that? ls/, oh, it's on here, isn't it? ls/munt, or here, one of the two. Oh, no, we're already in the right directory. Yeah, okay. So it's so I deleted all of these, as you can see. I deleted all of that stuff. And now that script has also repopulated the SD card firmware images in the platform directory on the FTP site. So recovery, it's this one. We've repopulated that directory with that script. But actually, first of all, let's check that let's pick this one here and then write it to the to the SD card. So we'll just generate the checksum of that file. So I've generated a checksum for the first 100K of the firmware image that I have now written to the SD card. So I've generated that firmware, that MD5 checksum, which is this. And then I've generated the checksum of the file itself, off the file system rather than off the SD card, and they are the same. So the first 100K is identical. So then the question, so that's good, because these are the correct files. So that's all good. So then I just need to check here in cd firmware SPI, xzcat checksums, fgrep that. Yes, okay. Right, so I found that that checksum does exist in the inventory here. So in theory, now I've rewritten that thing. Where are we? So this may actually provide... Oh, hold on. Is it because it's... Hold on. Is that actually the same? I've probably done something else wrong here. BE54569. Yeah, hold on. Let's have a look at the code here. Might have done something silly. Checksum. Oh, so it does. Yes, it does report back the correct checksum. Might have done something wrong. No. Okay. That's weird. Ah, right. Going crazy. Okay. Right, I know why it's not working. because this variable refers to the installed version of the checksums, which is not the one that I've just recreated here. SPI. So checksums. In fact, actually, tell you what, let's just rebuild the whole thing. So, I haven't got the package on there. I do on here though. So, okay. I think it stores it in /temp or something. Yeah. Right. Let's just rebuild this package. Okay. Right. Okay. Upgrade. Reinstall. If I do sources, bootloader flash. Yes! Okay. Right, it actually works. Great, so that's what the problem was. Okay, there we go. So we've read the checksum from the SD card, we found the file name, and determined the hardware profile. Great, okay, this works. Okay, so now I'm going to just get on with writing the code, and I'll show you guys once it's all done. So the code is complete. It's just basic shell scripting, so it's really easy to understand and also easy to use as a reference for other or future hardware models. Yeah, the only thing I've got left to do is just comment or delete this here so that it's not hard-coded anymore, and I'll do that once the tests are complete. But yes, it's all finished. I've thoroughly tested all of the workflows to ensure that the hardware profiles are correctly detected, that it handles more than one firmware version per hardware profile, and all the menus are correctly created, and that the flashing does work. The flashing code was copied from the Rock Pro 64s anyway, but I have tested everything now, and I'm pretty happy with it. And as you can see, actually, if I just page through, there's like not really that many pages of code, even in a large font. So and that's not even code, that's text. That's just the BSD license. So, you know, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, yeah, it's just big font. It's probably about 10 pages. It's you know, it's all just basic stuff as well. So, yeah, I've tested all of that. I've typed up the tests from the notepad and expanded them a bit. So I've got some actual test cases that I can use. So even though I've tested the code already in all of the workflows, I just want to finalize those tests, make sure everything's how it should be. The first test we're going to do is check that there's no known firmware version on either boot source. So this situation here that I'm testing for doesn't really capture any particular expected scenario. The way we're documenting it, you'd have at least one version of a known firmware version, either in the SPI flash or on the SD card, but I still need to check what happens when we can't find a known version on either source, even though it's not an expected scenario. That's just because it's quite realistic that somebody may, well, I don't know if it's really that realistic, but it's quite possible that somebody may build their own firmware from source, seeing as it is an open source firmware as well. So we need to handle a situation where we can't find a known version of the firmware on either boot source. So that's the one we'll begin with. And that means that we need to have an empty SPI flash, or at least an SPI flash that doesn't contain anything that's in our inventory. And the way we're going to do that is by flashing the Rock Pro 64 firmware to the SPI flash. That's already happened because I restored the Rock Pro 64 U-boot to the SPI flash in case the machine had a power outage while I wasn't using it. And then I'd have to unscrew the box or the case and then bypass the SPI flash and then boot and reflash the SPI. And I was like, okay, no, I'm not doing that. So the SPI flash is unknown it's not empty, but it's unknown as far as versions of the HoneyComb LX2 firmware is concerned. Okay, so that's that done, and we then need to empty the SD card as well. So I'll just show you that that's Bloodsuede, that's the build machine. There's Pepper. So bootloader flash. So I'll just show you. So this is going to show me, this is the Rock Pro 64 and Pinebook Pro bootloader flashing tool. So you can see at the moment that we do have a known version of U-boot, so that's okay. We actually only need to write 100K over the SD card because that's all we're checking in the tool. But I'm just going to put 1 megabyte because that's what I always do. Again, when I'm pasting anything in, I always prefix it with a hash, particularly if you're the root user, just for safety. Okay, so we're going to write basically nothing. We're going to zero out the first 1 megabyte of the SD card, and you can see fdisk-l. There's no partition table on the MMC block right now. There was previously when I was testing it. There was a FAT32 or something like that partition, but during the testing I've deleted it. All right, so let's wipe that out. There we go, 1 megabyte, and that's now cleared the SD card as far as the flashing tool is concerned, because again, we're only checking the first 100K. Okay, so yeah, the flash is empty as far as that's concerned. The SD card is empty. So now what we need to do is pop D return to the source, and we'll run the bootloader flash. Okay, cool. So the expected result is no hardware configuration profile is detected, and the flashing is mandated, which, yeah, is exactly it. There you go, flashing. We know which hardware model we are because that's detected at runtime. And there we go, flashing is required. And we've defaulted the option to yes. So you can still say no, we're not going to actually mandate you. I'm not going to force you to flash. We're not like that in Slackware. You can do what you like as you know, we give you as much freedom as you can in Slackware. I don't really like to force people to do things, but we're recommending you really that you need to flash it. Now I'm not going to flash because I already know that works. I just want to check the workflow. Okay, so that succeeds. Latest pass. So that's good. Okay, so the next thing we need to do is test how it behaves with known versions of the firmware on the SD card and on the SPI flash. So we need to check when the SPI has nothing recognizable, and that's okay because that's still the case because it has the Rock Pro 64 firmware on it. The SD card has a recognized image, so we've already done this step, but next I need to write a one of the recognized SD card images. So we'll take one of the ones that we're going to ship. So we need to enter into the platform directory, which is not here. Where is it? Somewhere. Platform arc bootware recovery LX. Okay, now I'm just going to pick one. It doesn't matter for the testing purposes. It doesn't matter because I don't even have a HoneyComb LX2 at the moment. But again, in the documentation, it'll explain which versions of these to use because this is regarding your hardware profile. MMC BLK1 is the SD card, so we'll take that there. Okay, so we've written that, and then we need to run the script again, and this time it should detect the hardware profile and it should mandate that the firmware is needs to be flashed, and it mandates that because there's nothing in the SPI flash. Bootloader flash, there we go. We detected the firmware, which is the version on the SD card. As you can see here, it says _SD, so we've detected that correctly. We have detected the correct hardware profile because 2 gigahertz SOC speed, 700 megahertz bus speed, and then 3000 or 3.2 gigahertz RAM speed. That's correct. It has detected the hardware profile, and it's surfacing here the firmware file from which it's determined the hardware profile. Now the thing at this point though is that, as we know, there isn't anything in the SPI flash that's usable, so this machine currently wouldn't boot from SPI flash, but I'm not surfacing that within the tool here because it's still possible that the user has something that is bootable in the SPI flash and it's just not a version that we know about, i.e. it could be their own self-compiled version. So I'm not surfacing the fact that, hey, you know, there is an SPI flash addressable, I just don't know what's in it, because it just really complicates the what's on screen really. It just makes it more complex or perhaps confusing for the user. And in the case of Slackware anyway, you can create your own version of the firmware if you want to, but really if you're going the Slackware route, just take the stuff we're shipping, which is from Solid Run. So I'm happy with the way that this behaves. The next is that the SPI flash contains a known version that is packaged. So to do that, we're going to use the tool to flash one of them and then rerun the tool. So let's rerun that again. And we are now going to flash it to the SPI flash. And at this point, you can see that it's now offering me a choice of hardware profile. It's defaulted to the version that, or rather it's defaulted to the hardware profile that it believes we currently use. And again, it's obtained that from the firmware that was on the SD card. I'm going to just pick another one. I'm going to pick the top one just so we've got, it's obvious or easy to see the distinction. So we're going to pick the 2.4 gigahertz profile, and then it's going to offer me the, in fact, actually, let's not do that. Let me pick that one, but I'll show you. I want to pick something else. So at this point, we're going to abort it because I just want to show you something different. So yes, I think it's this one actually, the 2600. So I'm going to pick this one because this here demonstrates that the tool is capable of handling more than one firmware version per hardware profile. So ordinarily, there's only going to be one firmware version for each hardware profile. That's how we're going to ship, at least initially. Maybe in the future we'll have other versions if people really need them, but probably they won't. But what I've done here, I've literally just copied I've copied this firmware version underneath with this one here and just made it 23Z instead. It's the same thing, but it's just literally just to test the tool that it can capture these firmwares. So I'm going to pick this version here, the second one, and then just press OK. Then we get the option to flash or abort, so you can always bail out at this point. Then we'll click flash, and this will take about 2 minutes. Almost done. Okay, done. Right, you run the tool again, and it should say, yep, there we go, detected the hardware profile that we selected, the 2.6 gigahertz one, and here's the file name, and we can tell that it's on the SPI flash because it's flex SPI NOR. Oh yeah, if you don't select anything, by the way, it tells you, hey, you need to select at least one of them, and then you can select one and then you can abort like that. So we finished that test, it works. The last test is what happens when we find old versions of the firmware. So what we need to do here is we need to flash an old version to the SPI flash. So I've found an old version here from the Solid Run website. So I'm just going to download that onto and then write it. So what I'll do here, push D. I don't think I have a user on this machine. No. Okay. Just make sure that. So I'm just. I don't usually download things as root like this. I switch to my usual pleb account. On this sort of test machine, I don't have a user account. So I'll just use the nobody user and make a directory in /tmp so that it can write to, so it can download the files. And then I'll just switch to the user nobody. Now, if you do it like this, it doesn't switch to the user nobody, and that's because the shell is false here, so it's bin/false. So you can't do that. So you have to specify the shell like that. Okay, /tmp, and then I've got that. No, I need to select the line again. So just download that like that. Okay, and then we switch back. So I leave the shell, or rather I leave the shell of the nobody user, switch back to /tmp. There's my file. How big is that? 1.6 meg. So that's the SPI. Yeah, cool. And then we just need to flash it Oh, actually, I need to unpack it first. So unpack it to /tmp/firmware bin, and then write that to the flash like that. All right, that's complete. So, right, and then we run the tool again, and the expected results is the hardware profile and file name is populated and flashing is suggested. Okay, so popd, okay, /bootloader. Coolio. Okay, there we go. You can see that's the version that we wrote. Double check, 2970. Yeah, okay, looks good to me. And you can see it's SPI NOR. And even though, again, at this point, there is a valid version of the firmware in the SPI flash, but it's not one that we are packaging. We have a newer version. And so we're suggesting, we're not mandating it, but we are suggesting that you probably should. Okay, so we'll put no for that one. So that works. So to do this, we want to empty the SPI flash for this test because we already know that we can detect the correct version from the SPI flash. And the reason why is, or rather the reason is because when you look at the for scandev, the order is important here, and that's why I need to reflash the SPI flash, because we check the SPI first before checking the SD card. And if we find ourselves a known version of firmware in the SPI flash, then I think we break. Yeah, we break. So we exit this loop here, and so we'd never check the SD card. So we need to make it so that the SPI flash has nothing known on it, so that we fall through to checking the SD card. So right, where's the specs again? Specs. Right, so what do we need to do? We need to restore the Rock Pro 64 firmware so there's nothing recognizable. So bootloader flash RK339. Actually, I just had a thought. Did I? Don't think I did actually. So to the Rock Pro 64 tool, I added the option to abort before you committed to flashing, because I realized that we didn't have that in there, and I thought that was quite useful. Slackware. I think I didn't install it on here though. Oh no, I did. Okay, cool. Bootloader flash. Okay. I thought I didn't have the latest version on this machine, but I do. I must have done it yesterday. Right, so you can see we're using the Rock Pro 64 flasher now, and the version of U-boot is unknown, or it's a non-Slackware release, and we need to flash it. So yeah, let's flash. And again, oh yes, there we go. So you've got the option now to abort or flash. So we'll flash the Rock Pro 64 firmware or U-boot bootloader back to it so that we can actually have a bootable machine again, because the next test is what happens within the installer. Okay, done. Right, so that's done. So that's now empty. Write an old version of the SD card image to the SD card. So I'm going to download this version like that. Switch again to nobody. I can delete that, don't need that anymore. Let's download this. Okay, so that's the SD card version there. And then I just need to write that to the SD card. Oh, which I need to be root to do. Oh, hold on, that would probably need unpacking. Oh, it does. Oh, okay. Oh, yeah, because it's DD. So it just unpacks it and pipes it into DD. All right, cool. So, but that needs to. I need to put /tmp/firmware there. Firmware. There we go. Coolio. Oh, there we go. To remove the hash. All right, that looks good to me. 3. Yeah, looks good. .bootloader. There we go. Okay, again, we know there's nothing in the SPI flash, and we determined the hardware profile from the SD image, and we're saying that, hey, yeah, we found it, but it's an old version, you should flash it. I'm now satisfied with those tests, and the only thing that remains is to ensure that the flasher works correctly within the installer so that we don't break anything. I'm going to reinstall this machine. So I have a tool that writes the naked or the bare version, I think, no, the bare version of the installer here, but because it uses the boot partition to determine how to address the SD card. I need to really change that script to make it not care about that stuff. But okay, so let's just see. I'm not going to do that now though, but DD, where is it? So I just need to do that. Whilst that's happening, I need to build a package of the bootloader. At the moment, this is not entering into the Slackware ARM tree. It's just going to pop it in a temporary location because it's not ready for distribution yet. So I'm going to move that into storage where I can find it. The only thing left to do is just remind myself of how I can pause the installer before the post-installation scripts kick in. And that, I think, is in here. So this is an addition I've made to the Slackware ARM installer. Maybe I'll upstream this at some point, but I've got a whole bunch of stuff to upstream for the installer. I need to get around to it. Okay, so that's how we do it. If there's a file called that, then we pause and don't run any of the scripts. Okay, cool. So how are we getting on with this? Done. All right. So we have now written a new version of the installer, or the latest version of the installer, to the machine, and I'm logged in now over the serial port, so I can reboot Pepper, and hopefully this machine will. I flashed the SPI flag. Good. Yeah, so this machine has now the RockPro 64 version of U-Boot in the SPI flash once again, not the solid run firmware, and it's got the Slackware installer on the SD card, so it should all boot correctly into the Slackware installer. Yes, here's U-Boot right there. Okay, so we'll boot the Slackware installer. So I need to create this flag here, and then we can run setup. Yep, like that. You know, actually, don't know what that is. Let's try that. Ah, there we go. Right, there we go. So thank God, it's been annoying me for ages. So if you're running the Slackware installer under screen and you get really irritated by the lack of full block coverage, or color coverage, then you can CD into, or you actually don't CD into there. You can just export the terminal setting of screen.linux-s, and then you'll see that it has full color coverage. There we go. Okay, so don't care about the key map. Let's just add swap. The partition table and everything is already created. Okay, and we're going to install over NFS because this version of the installer doesn't have the package set on Slackware AR64 current /Slackware. Okay, do you know how many times I've typed that in over the years? Countless times. All right, looks good to me, and we'll just install everything. Okay, so we'll come back once that's finished installing, and then we'll just finish off the sanity tests. You can see that the installation has now completed, and the installation process has been paused. Okay, so what we're going to do is press Ctrl Z to pause that. Now, at this point, we have the OS, which has been installed onto SDA2, which is in //MNT. Now, what I need to do is install the new firmware flashing tool package into the OS so that the tool is run as part of the post-installation phase, so we can see how it behaves and make sure it works. So what we need to do, I'm just going to make a let's make a directory, an installer, no lock slack tmp. Now, root equals /mnt install all package hwm bw. I can supply the variable root to install package and setting the what install package considers to be the root of the environment into which it's installing the package. I can set that like that to override the / or the defaults rather, and then just install it. So this will now install the package into the OS, and we can see that munt user. Now where did I put it? It's probably sbin, isn't it? Bootloader, yeah. Flash LX. Okay, yep, there we go. Cool. And also we should see its install script, lib/package tools scripts. Oh, that's quite a few. Hold on. No, it's not scripts. It's setup, I think. Yeah, there we go. So we should find that this runs from within the installer, and it should run ahead of the Rock Pro 64 one. As it happens, it doesn't really matter, but at this time. But okay, so that's installed. We've got the package installed into the OS, so we can now proceed with the post-installation phase. Let's see what happens. It's synchronizing the OS init.rd. Okay, I can remove the installer. We're updating the font inventory. There we go, it works. Cool. So as you can see, the flashing tool has run inside of the post-installation phase, and it couldn't detect the hardware configuration profile, and it's telling me that flashing is required. Now, of course, this is correct. We're running on a Rock Pro 64, but at the moment, the flashing tool is hard configured to believe that it's running on a HoneyComb LX2. So on a Rock Pro 64, ordinarily, this script will never run. It'll just detect that it's not running on an appropriate machine, an appropriate hardware model, and it will just exit silently. So you'll never see this. Now what I'll do though is I can run through the workflow, but I will not flash it. So here we go. We're offered a choice of hardware profiles. So I'll pick the 2.6 gigahertz profile. So it's offered me the firmware options. There's only one. That's fine. Select that. And I'm not going to flash it at this point because I know that the flashing code works because it's taken from the Rock Pro 64 tool. And so we can do that with Brent. So I can abort that. Then we can continue with the final post-installation setup. So let's pick a mouse, pepper, use network manager, yeah. Select RPC, I tend to use that. No, I don't care about the time really. Yeah, KDE. Okay, and so the machine will now reboot. Well, I'm happy with that. It works, the tool works outside of the installer and works within the installer, at least on my Rock Pro 64, and I'm happy now to turn it over to Brent and he can test it within the installer on an actual HoneyComb LX2. I hope you found this episode useful and interesting, and I'll see you in the next episode. Take care. High marks look kind of fresh. Got no idea where I am now. Where? I'm going to take a shortcut through. I think this is the right direction, but I don't know. It's hard to say. I'm certain I've already been here. This is a word of warning. Don't think too deeply about your open source projects. Don't think too deeply about your open source projects when you're out and about in an unfamiliar area, because you might get lost. Usually, I pay attention to my, my sort of internal kinesthetic compass, but today I was so deeply in thought about the flashing tool. Ooh, here's a path. I did it in New Zealand once as well, and I spent like hours, 5 hours walking around the wilderness trying to find where I parked my car. It's down here. This is like being in the Blair Witch Project. Everything looks the same. No matter which path I take, it feels like I'm just going around in circles. Fungi. Sometimes you see people out foraging here. There's all sorts of stuff. One guy told me there was something called chicken of the forest. It looked like a piece of chicken thigh attached to the bark of a tree. People.